Have you ever wondered how Ferris wheels go round and round, or how your voice makes sound waves? It's all thanks to trigonometry. And the best part? We can visualize these patterns with cool things called graphs. These graphs, like magic, unlock the secrets of waves, circles, and so much more. Imagine a right triangle inside a circle. This setup is the foundation of trigonometry, where the circle represents a unit circle, and the triangle helps us understand angles and their relationships. Now picture one angle moving. That's our star player. As this angle rotates, it creates different scenarios for the triangle's sides, giving us a dynamic way to explore trigonometric functions. Sine, cosine, and tangent are like its trusty sidekicks, telling us the ratios of the triangle's sides as the angle changes. These functions are essential in various fields, from engineering to physics, and even in everyday problem solving. Sin, is the shy one, focusing on the opposite side to the angle divided by the long side, hypotenuse. It's crucial for understanding wave patterns and oscillations. Cosine, is all about the adjacent side to the angle over the hypotenuse. This function helps in calculating distances and is widely used in navigation and computer graphics. And tangent, it's the adventurous one, looking at the opposite side divided by the adjacent side. Tangent is particularly useful in understanding slopes and angles of elevation or depression. Let's graph them. Graphing trigonometric functions can be a fascinating way to visualize how these functions behave over a range of angles. We'll put the angle along the x-axis. This axis will represent the input values, which are the angles measured in degrees or radians, and the sine, cosine, or tangent value on the y-axis. This axis will show the output values of our trigonometric functions. For the sine graph, as the angle goes from 0 to 360 degrees, watch the y-value dance up and down, creating a smooth, wavy line. This wave is periodic, meaning it repeats itself at regular intervals. This wave represents how the opposite side of our triangle changes in relation to the hypotenuse. The sine function is crucial in understanding oscillatory motions, like sound waves and light waves. The cosine graph is similar but starts at its highest point. It also creates a wave, but this time it begins at a peak and descends. It also makes a wave, but this time it shows how the adjacent side relates to the hypotenuse. The cosine function is often used in physics to describe waveforms and oscillations. Finally, the tangent graph is a bit wild. Unlike sine and cosine, the tangent function can grow infinitely large. It zooms up and down with these lines called asymptotes, where it leaps to infinity. These asymptotes occur at odd multiples of 90 degrees, where the function is undefined. It's telling us that as the angle approaches certain values, the opposite side gets really large compared to the adjacent side. The tangent function is particularly useful in engineering and physics for describing slopes and angles. So why should we care about these graphs? Well, these graphs aren't just pretty shapes or abstract concepts. They help us understand everything from the harmonious notes in music to the flow of electricity in circuits. They help engineers design and build sturdy bridges, predict the weather with greater accuracy, and even send rockets soaring into space, navigating the vast cosmos. Next time you hear a sound, ride a Ferris wheel, or see a light wave, or gaze at the stars twinkling in the night sky, remember the power of sine waves, cosine waves, and tangent graphs. They're not just math equations scribbled on paper, they're the secret code to understanding the universe and its many wonders.